Hello and good evening, and welcome to the continuation of our Juniper and Cisco OSPF interoperability tutorial series here. We're going to take a look in this video at setting up Ipv6, and we're also going to go ahead and set up the load balancing load balancing on the Juniper side of the house. As we saw in the first video, Juniper does not load balance by default across equal cost paths, and we have two equal cost paths here. Again, we've got the exact same setup as we had before, so let's go ahead and jump back into the configuration section on the Juniper side of the house. So let's go ahead and we'll set up Ipv6 first. So I'm in operational mode. I'm going to move into, whoops, sorry, wrong command on the wrong side there. I'm going to go ahead and jump into configuration mode here. And we're going to put Ipv6 addresses, and we're going to configure up OSPF3 on the Juniper side. So if I were to say top, edit, protocols, OSPF, and type in show, you can see we've got our reference bandwidth from yesterday. We've got the interfaces that are in area 0. And let's go ahead and set our router ID. So I'm going to say set router, wait, I'm sorry. I want to go into routing options for that. Top, edit, routing options. There we go. So actually, I think it should already be set. Yeah, okay, so we've already got that set. So we'll go ahead and say top, edit, protocols, OSPF, and actually, I need to change that to OSPF3, right? So instead of saying, like on the Cisco side, you'll see that we're going to be using the Ipv6 OSPF command. Here we just simply say top, edit, protocols, OSPF3. If I type show, you'll notice we don't have any interfaces yet, so let's go ahead and add some in. So set area 0 interface, and we're going to use loopback 0. We're also going to drop in here Gigi000 and Gigi001. So now we've added those into the OSPF configuration. If I type show, you can see that this is the configuration under the edit protocols OSPF3. So if I were to say run show config, well, actually, let's do a commit here real quick. So we're going to commit the changes. While that's committing, let's come over here and, whoops. So we'll have to wait for that actually to finish. All right, so if I say run show configuration here on the Juniper side of the house, let's scroll down to the OSPF section. And as you can see, we now have, under protocols, we've got OSPF with the interfaces that are participating with OSPF. And then we also have the OSPF3, which is OSPF4 Ipv6. And then let's also go ahead and say set our reference bandwidth as well on the Ipv6 side of the house, and let's commit that change. All right, so over here we'll move into enable mode. All right, so now let's go ahead and go top, edit, interfaces, loopback 0, and we're going to go ahead and drop this interface now into sort of our OSPF. I'm sorry, we're going to go ahead and put on our IP addresses. So we're going to say set, and you don't need the unit 0 on the loopback interface. So we're going to say set, and we're going to go with family. Oops, sorry. Let's make sure I get this right here. So we're going to say set, and I am under loopback. Is that right? Yeah. Do we need it? I guess maybe I do need the unit 0. I apologize there. Set unit 0. Yeah, okay, family. INET 6, right? So INET 6 is going to be for the Ipv6 configuration. And address. So let's put our link local on here, FE80::2. And then we're going to go ahead and add in the Ipv6 address, a global unicast address of 2001 DB8:2:2/64. So that's our loopback interface. Then let's go ahead and say top, edit, interfaces, Gigi000, and we're going to do much the same. So we're going to set the link local address and the global unicast address. and I'll just set this to : : actually I wanted to leave that as colon. We'll leave that as 2. I'll use 22 on the interfaces, and then finally we'll go ahead and say top edit interfaces gigi 001, and again we'll use the same link local address, and we'll set this guy to 222. Alright, so let's go ahead and commit these changes. And I'm going to go ahead and kick off a ping. So let's say run ping 2001 : db8 : 22 : 2, or actually 22 : 1. And yes, okay, so it doesn't know. Oh, sorry about that. 2001 : db8. I left out my second colon there. So there we go. So it's pinging, right? However, it's going to come back destination unreachable. We haven't configured anything over here on the Cisco side of the house. So we'll let that ping run. And on the Cisco side of the house, let's go ahead and go to global config, and let's turn on IPv6 unicast routing. And I'm going to go ahead and say, let's get our interfaces done up first here. So interface loopback 0. IP address is going to be 2001 : db, or IPv6 address, 2001 : db8 : 2 : 1/64, or actually we'll go ahead and make this 1 : 1/64, and then we're going to put on the IP, well actually we won't put a link local on here, and then let's jump into the interfaces. So we'll say interface fast Ethernet 00, we'll say IPv6 address FE80 : 1 link local, and then IPv6 address, and this is going to be 2001 : db8 : 22 : 1/64, and take a look at that. As soon as we dropped on the IP address that we were pinging, now we've got connectivity and everything's working great between these two components. So let's go into FA01, and we're going to say IPv6 address FE80 : 1 link local, IPv6 address 2001 : db8 : 222 : 1, sorry, : 1/64. All right, and do show IPv6 interface brief. So those interfaces should be up. Now we haven't done any configuration work. If I say do show run section OSPF, you'll notice there is no configuration yet for OSPFv3 for IPv6. So let me kill this from running here. So we've established we've got connectivity. Let's ping 222, right? So the Juniper router can ping both of the Cisco routers interfaces with IPv6, so that's a good sign. Now let's go ahead and configure the OSPFv3 settings on the Cisco side of the house. So I'm going to say exit, and we'll say IPv6 router, IPv6 router OSPF, the process number, and we'll just use 1. And I'm going to go ahead and say, log adjacency changes, auto cost, reference bandwidth 10,000. And now we need to put the setting under the interface. Remember, on the Cisco routers, the only way with OSPFv3 to actually activate and start the OSPF process on an interface is to do it under the interface configuration mode. Remember, there is no network command here, right? You don't see any network command like you did with OSPFv2. So let's go ahead and say interface loopback 0. And we'll type in IPv6 OSPF1 area 0. We'll go into interface FA00, IPv6 OSPF1 area 0. Now, after I type this command, we should see an adjacency established, interface FA01, and we're going to say the same thing, IPv6 OSPF1 area 0. Now, you'll notice that we don't see the adjacency forming. So when I say do show IPv6 route, you'll notice we see the directly connected routes, And then we also see the local entries that correspond with those directly connected interfaces, including the loopback address. So if I were to say do show run interface FA00, you can see that we have our IPv6 addressing on here and our link local addressing, right? However, do show IPv6 OSPF neighbor, we don't see anything. And then let's come over here and say run show OSPF neighbor, right? Now, if for OSPFv3, I just put OSPF3. So I see neighbors on the OSPFv2 side, but I don't see any neighbors on the OSPFv3 side. So let's say run show configuration. And we're going to come down and we'll see that we've got our link locals are showing up here as /128. So let's go ahead and type in here top edit interfaces, and we'll go to GigE000. And I'm going to say delete, where are we at here? Delete unit 0, family inet6, address FE80, FE80::2 /128. And I'm going to go ahead and set unit 0, family inet6, address FE80::2 /64. And then let's commit this. And let's see if that changing it from a /128, which is basically a host route like for IPv6, does that have any effect at all with the adjacency? Or should it make any difference at all with the adjacency? And so as you can see, it doesn't, right? It's not having any impact at all. So let's go ahead on the Cisco side. Let's do a do show, whoops, I'm sorry. And there we go. So it went from loading to full, right? So now when I say do show IPv6 route, you can see that I'm now picking up the routes. And this is something that I noticed earlier, is that with the link local addresses, if it's a /128, for whatever reason, if I say do show run IPv6 OSPF neighbors, or I'm sorry, do show IPv6 OSPF neighbors, and that T keeps getting me. There we go. You can see that we only got the adjacency out the fast Ethernet 00, because for whatever reason on the Juniper side of the house, there isn't a link local option, and if you don't put anything in there, it defaults it out to a /128, and it will not form an adjacency, right? Because again, /128 is like a /32, so in terms of the prefix length, it's not going to establish the adjacency because there's no room in that prefix length for any other IP addresses. So when I change it to a /64 though, the adjacency comes up. So let's go ahead and confirm that that's the case. So we'll say top edit GE001. Oops, sorry about that. Top edit interfaces GE001, and we'll do the same thing. We're going to say, whoops, delete unit 0, family inet6, address FE80::2 /128, and then set unit 0, family inet6, address FE80::2 /64, and then let's commit that. So the commit's complete. We'll give it a second for the hellos to go back and forth on the IPv6 side of the house, and we should see here that the adjacency will establish, and there it is, right? And the adjacency establishes up over the fast Ethernet 01 interface. So on this side, again, when I say do show IPv6 OSPF neighbor, you can now see that we have two adjacencies, right? One out fast Ethernet 01, and then the other adjacency out fast Ethernet 00, both over to the same router, right? Because here's the router ID for the Juniper router. You can see the priority for the Juniper router is 128, right? By default, it's 128. The Cisco is by default 1. So if I were to say run show OSPF3 neighbor detail, we get much more information with the detail option. You can see the state is full, and here is your priority of 1. So who's the DR? Well, the DR is shown as the Cisco router. The BDR is shown as the Juniper router, but that's because the Cisco router elected itself first. So let's say do clear IP OSPF or IPv6 OSPF proc. So we'll say yes. So this is going to clear the adjacency, and it's going to have to reestablish the adjacency from scratch. And so now let's rerun this command, and this is what we would expect to see. So now the DR is the router with the router ID 2222, and that's our Juniper EX3200. You can see the backup designated router is now the Cisco router, and again, it's because of the higher priority, right, of 128. Okay, so now that we've got OSPFv6 set, OSPFv3 for IPv6 set up, we've got OSPFv2 for IPv4 set up. If I say run show route on the Juniper side of the house, this is the loopback address 1111 over here on the Cisco router. So if I were to say run ping 1111, we have connectivity to that address, right? Because it shows up here in our OSPF routing table on the Juniper side. However, the greater than sign, and this is very similar to the BGP output on the Cisco side, right? So this is the selected path. So now you'll notice that it's not going to load balance across these two paths. It has selected this path as the path that it's going to take. So if I were to say run trace 1111, we'll see that it doesn't go over both paths. It only selects 10221 as it shows in the routing table, and it picks that every time, right? So if I were to say run show forwarding option, run show route forwarding table, right? What do we see in the forwarding table here? And this is the equivalent to the fib, right? So this is the interface out which it is going to send traffic that is destined to the 1111/32 network, right? It's going to go to the next hop 10221. You can see there that does not have multiple listings here, and just like you saw in the routing table, it is going to randomly select one of those interfaces out which to send the traffic. Now that's very different than the Cisco side of the house. So if I say do show IP route over here, you can see that we have two equal cost paths, right? And when I say do show IPsef for 2.2.2.2/32, the Cisco forwarding table, right, the fib, actually installs both routes, right, or both, basically it installs both routes, both paths to get to that interface. So how can we check to see if it's going to do this? So you can use traceroute, but I'm going to show you, we're going to do an extended ping here. So I'm going to say do ping. We're going to ping the loop, oh, sorry about that. Do ping IP 2222, and repeat count is fine, datagram is fine. Now we want extended options here. So source address or interface, well, let's go ahead and use our loopback address. No type of service, no DF bit. Now, when we get here, let's use the record option. Now the record option is going to show us which way the ping packets go in each flow, right? So because ping in general, if I were to just simply type in ping 2222, that is not going to get load balanced, right? Because those ping packets are all considered to be part of the same flow. However, when I do the record option, it's going to do it multiple times, and each time it does it, it's going to treat it as a new flow. So let's watch what happens here, and we'll do that. All right, so take a look at what happens down here now when it says record route, and it's going to give us the outgoing interface. So here we go. It went to 10.1.1.1. So that's the outgoing interface on the Cisco router, and then it goes over to 10.2.2.2, and it's going to show us how it works its way back. And it should go to our loopback address next, and it did. Now, here's the next request that goes out. And this is treated as a different flow. And take a look at that. 10.2.2.1. So you can see that the first flow goes out 10.1.1.1. The second flow goes out 10.2.2.1. Now let's watch and see what happens as it works its way on the next request. And it should be 10.1.1.1, right? Because it's load balancing, and there you go, 10.1.1.1. So as you can see on the Cisco side of the house, right, it's going to go ahead and automatically load balance for us. The Juniper side does not. So how do we configure the Juniper side to go ahead and do that? Well, the first thing we need to do is we need to create a policy statement, and then we need to apply that policy statement to the forwarding table. So let's go ahead and do that. So we're going to say top edit, oops, sorry about that. So we'll say top edit policy options, right? So it's under the policy options area where we're going to set a policy statement. Now, I'll do a question mark here. This is just the name, right? So I'm going to call this load balance all. And because again, we're not actually picking, and I'm going to do that here in a second, where we selectively load balance for certain destination prefixes, but right now I'm just going to load balance for everything, because again, we've really only got one address, one loopback address that we would go to anyway. So I would say policy statement, load balance all, then load balance, and now what are our choices for load balancing? You'll notice it says per packet. Well, it's per packet if and only if you've got you're using legacy equipment that would be using what Juniper called the Internet Processor 1 ASIC, right? So the Internet Processor 1 ASIC, that ASIC would do per packet load balancing, which is not a bad thing, but can be a bad thing. Because if you're experiencing latency and you're breaking the packets up over different paths, if they're arriving out of order, that's going to cause overhead to have those reassembled and put back in the correct order. Which is why, by default today, right, on the newer platforms that Juniper has on the market, they have what's called the Internet Processor 2. And the Internet Processor 2 load balances on a per flow basis, right? So even though you put per packet in here, it's not actually load balancing per packet. It's per flow. And remember, that is if you have the newer equipment, right? Internet Processor 2 functionality, and not the older legacy equipment. So you would, it's again, platform/hardware dependent. So check in your documentation to see what the ASIC is that you've got, right? If it's the Internet Processor 1 ASIC or if you've got the Internet Processor 2. So again, even though I'm putting per packet here, this is going to load balance per flow. And you'll notice there is no per flow option, and that's something I've always been curious about, as to why don't they just put per flow in here to give you an option to select per flow. But the reasoning that at least what was explained to me was that, well, even if you put per packet, it's still going to do per flow if you're using the newer architecture. But it would be nice to have it say per flow in here. Okay, so we're going to type in per packet, but again, this is going to do it per flow, right? So I'm going to go ahead and hit enter on that. Now, we've created the policy statement. So now what we're going to do is we're going to go top edit routing options, top edit routing options, and I'm going to apply this to the forwarding table, right, or the fib. So basically what I'm doing here is what's being done automatically for me on the Cisco side via Ceph. I'm actually telling the JuneOS forwarding table that I want you to load balance per flow across to all destination prefixes, right? So I'll put in here set forwarding table, and then we're going to say it's export. Yeah, export. So export, and then the name of our policy statement. Well, we just called it load balance all, right? Or LB-ALL. Now, so this is interesting. So remember, I haven't committed anything yet. So if I were to say run traceroute to 1111 and hit enter, you'll notice how many paths does it take and which paths is it taking. It's only taking that one path that it has selected that is in the routing table, right? And that as a result is also that shows up in the forwarding table. So now let's go ahead and commit, basically enabling equal cost multipathing to all destination prefixes. So there we go, commit complete. So now I'm going to come back and let's run that trace route again and take a look at what happens immediately. So the first one goes to 10.221, right? And this is the next hop address. And then where does the next one go? 10.111. And that's very different than what we saw up here, isn't it? So now it's load balancing. So let's run it again. So 10.221, and then it's going to show up and go to 10.111, right? So now it's actually load balancing per flow, right? So let's go ahead and type run show route forwarding table, and let's see what we see now for the destination prefix 1111. So I've got everything highlighted here. So as you can see, right, we now have one route here and one route here, and it's out those two interfaces, and we've got this new line here, this ULST. And what that stands for is Unicast list, which means we have more than one path to get to that prefix. And here is the next hop address. Again, that's the Cisco FA00, and this is the Cisco FA01, right? The 221 and the 111. Now, let me go ahead and clear that off. Whoops. Now, prior to this, prior to enabling the load balancing, we did not have a Unicast list entry. We simply had just the Unicast entry for the route that it was using, which was via that next hop, right? So now we've enabled equal cost multipathing across the two paths. Let's go down just a little further here. And this is something to note, is that by default, IPv6 on JuneOS, and we'll come back to this, I want to show you now what it looks like, but IPv6 by default is supposed to load balance automatically. We don't have to enter anything in. So we'll come back and we'll double check, because I'm going to simply delete the routing option that we just put in, and we'll see what it looks like after we fix it. So what if I say run show route? Does the routing table look any different? It really doesn't, right? So it still shows the two hops, and we've got this greater than sign here giving us the impression that it's only this path. However, it's not. We know that we've set it up to go to both paths because the fib, or the forwarding table, is showing us that information. So run show route forwarding table, we have it right here. So here are the two equal cost paths that we have installed in the forwarding table. And again, that trace route command that we ran earlier is proving that it is jumping across both of those paths, right? As you can see right there. Okay, let's go ahead and turn it off. So we're already under routing options. If I type show, we can see exactly what we have in here. So I'm going to basically say delete forwarding table export lb-all. Let's commit that change. And so now it's out of there. So how do we confirm it's out of there? Well, let's go ahead and run our trace route. So if I do this, it should still be using the original path that was in the routing table, and there it is right there. 10.221, right? No reference at all to 10.111. It's going out on this side. It's going on the egress interface is the GE001. And the destination interface on the other side, the next hop interface on the other side, the Cisco router is FA01, right? So in a sense, we've broken that equal cost multipathing that we had. So let's now say run show, I'm sorry, I keep forgetting the route in there. Run show route forwarding table. Because if IPv6 load balances by default, the fib should reflect that. And let's see if in the IPv6 area, is it there? You'll notice that it is not, right? So I've seen in documentation where it says that IPv6 does it by default. However, here, unless something is misconfigured, it is not doing it by default. So IPv6 is not doing equal cost multipathing by default. In fact, if I were to say run traceroute, let's go ahead and dump in this address. And you can see that we jump over to 22::1, which is FA, I believe that was FA, do show run int FA00. Let's confirm that. Yeah, it's coming over to FA00. Right? So it's not load balancing. You'll notice it's not picking any other interface. Right? So let's take a look at the Cisco side. If I say do show IPv6 route, do we have two equal cost paths? Over to the loopback address of the IPv6 loopback address, which is, have completely forgotten what the IPv6 loopback address was that we set here. And it should be this guy right here, 2001 DB8:2:2 is the local. Is that what we have the route? Yeah, 2001 DB8:2:2. So let's go ahead and try our extended ping again. So if I say do ping, we're going to say IPv6, target IPv6 address. Let's go ahead and cut and paste DB8:22. Is that the right one? ::2. Yeah, 2001 DB8:2:2. So let's put that in here. Repeat count, datagram size. I wanted extended commands. Sorry about that. And you can see, obviously it worked. Do ping IPv6 and the target address, paste. All right, so let's get to extended options. We'll say yes. And let's see. So source address or interface, we'll use our loopback 0, which is 2001:DB8::1. Sorry about that. Yeah, that is loopback 0. There we go. Copy, paste. All right, so we'll use that as the source. No UDP, no verbose, no precedence. DSCP hop option. Is it going to allow us to do the record? So there's no record option. It doesn't appear with the IPv6. So let me see if it'll let me trace this out. So let's see if the trace is going to show us that it's going to use both exit interfaces to get to that destination. So we'll give it a second here. And no, it just simply jumped over to the next hop. All right, so on the IPv6 side, let me go ahead and turn the option back on this side. So again, I would just simply say set forwarding table. What's our export policy going to be for the forwarding table? It's going to be load balance all, because we still have that policy option set. I'm going to commit. Then we're going to take a look at the IPv6 forwarding table. So we'll say run show route forwarding table. Let's see if we have it for IPv4. So here it is installed again. And here it is for IPv6. So let's see what happens here when I say run trace over to 2001:db8:1:1. And does it go out? So it goes to 222, right? Which is on FA01. And then here's 22:1. So it is load balancing again, right? So the routing options, when we apply it to the fib, it actually applies to both IPv4 and IPv6. Well, what if we only wanted to load balance to, let's say we had a certain set of destination prefixes? And so I'll do this on the IPv4 side. I'm going to create some loopbacks. So let's say interface loopback 1, IP address 192.168.10.1, IP OSPF1 area 0, interface loopback 2, we'll say IP address 192.168.20.1, and then we'll put in one more here, IP OSPF1 area 0. Let's drop in interface loopback 3, IP address 192.168.30.1, IP OSPF1 area 0. And so that should do it. Let's take a look at the routing table here to see if the Juniper router is picking things up. So run show route, and we should see some 192s in there. And we do. So there's our 192.168.10.1, .20.1, and .30.1. We can see we've got two paths. Are we load balancing? Let's take a look at our forwarding table. And here come our 192s kind of in the middle. And sure enough, we are definitely set up for equal cost multipathing on the JuneOS side. So what I'm going to do now is I'm actually going to change the policy option statement that we had created. So I'm under the routing options. Let's do show. I'm going to go ahead and delete this guy again. So we're going to say delete forwarding table export lb-all, and that removes that. And then I'm going to say top edit policy options, and I'm actually just going to go ahead and create, if I type show, you can see we've got this policy statement here. There's no reason for me to, I don't have to delete this, right? Because this policy statement, this is just simply, think of it as like an access list, right? So it's like creating an access list. It's not going to do anything unless I actually apply it to an interface, or use it in a route map, or apply it to a VTY line. So I can leave that defined here. There's nothing wrong with it. And then if I wanted to use it at a later date, then it would be available for me to use. I wouldn't have to reconfigure it. So we're just going to leave that here, because again, it's not doing anything, simply being defined under the policy options area. So what I'm going to say now is we're going to say set policy statement, and again, just the name of the policy statement. So I'm going to say this is going to be load balance 10, 20, whoops, and 30. So that's what we're going to call it, LB-10-20-30. And so I'm actually only going to set this up to do load balancing to those destination prefixes. All right, so we've got the name in here, and we're going to say from, excuse me, route filter, and now I need to put in what routes am I, what destination prefixes do I want to use. So 192.168.10.0/24 exact, and then we're going to do 20. Oops, sorry about that. Do 20 and then 30. And now let's go ahead and type. So now we have our from statement in there. And actually, I now need to get my then statement in there. So that, let me rerun that. Actually, let me rerun that. I forgot to put my then statement in there. So we'll go back to 10. So exact, and if I do a question mark, you can see that. And where is that at? Yeah, it doesn't like that. Set exact, and then so we've got our policy statement, load balance. So set policy statement LB-10-20-30. There we go. Sorry about that. All right, 10-20. So if it matches from those routes, or we're going to those destination prefixes, then what do I want it to do? I need to put in here, I want it to load balance. And again, you can see there's no per flow option. It's just per packet. You just have to know if you've got the newer Internet Processor 2 functionality or the legacy Internet Processor 1 functionality. Another significant difference between those processors, or the processor 1 ASIC and then the processor 2, is that in terms of equal cost multipathing, with the legacy ASIC, the limitation was 8 equal cost paths. With the newer processor, you can do up to 64 equal cost paths on a per flow basis. So even though it says per packet here, it means per flow. All right, so now let's do a show, and we should have that. There we go. Then load balance per packet. Okay, so we've got that policy statement in here. We've got our route filter defined. Let's go ahead and apply this to the forwarding table. So top, edit, routing options. And if I do a show here, we should have just the router ID, because remember we deleted out the previous one. So I'm going to say set forwarding table export, and this is going to be LB-10-20-30, and that is it. So let's go ahead and actually right now, if I were, before I committed, if I said run trace to 192.168.10.1. Oh, I left it on, didn't I? Actually, that's right. The policy was left on. So we'll say commit, and that's okay, because we left it prior to this. It was doing load balancing over all paths, which is why it hit. Sorry, I thought I'd pulled it off and then committed, but we didn't commit. Okay, so what happens now if I say run trace 1111? There's no load balancing taking effect here. Do you see that? So again, it's going back to what it did previously, which is simply using the one path that it is sticky with, right, or glued to, which is that path out the GIGI 00 interface. Is that right? Or GIGI 001, sorry. So if I were to say run show route, as you can see here, the routing table realizes there are 2 equal cost paths. However, this is the selected path. So now let's say run show route forwarding table. And here you go. The 1111 is simply a unicast route, and it's going out one interface. So let's take a look at our 192.168s. Same thing, right? And they've randomly picked out which interface they're going to go. So let me take a look at the export LB-10-20-30. Let me make sure I've got this right. Top, edit, policy options, show. All right, so we're having some issues there with getting the load balancing to work. So if we take a look at the policy that we've set, or the options that we've got set, we've got our export statement is correct. So if I were to say top, edit, and we'll go to routing, or actually we're in routing options. So top, edit, and then, whoops, policy options, and I do a show, you can see that what we've selected here is we're saying /24 and exact. Now remember, with OSPF, the default network type is point-to-point. So when I say run show route, take a look at how OSPF is learning these routes, right? It's learning them as /32s. So if we want to change that on the Cisco side of the house, what do we need to do? Well, we need to change the network type. So if I were to say, go into global config and say interface loopback 1 and say IP OSPF network type, whoops, network type, sorry, network, point to point, right? Over here, if I were to do the run show route again, do you notice any changes? Now it matches. So that policy that we've applied, so when I say run trace to 192.168, whoops, 192.168.20.1, it should not work, right? Because it's not going to match that prefix because it's a /32 in my routing table. It's not a /24, but since we've made the change on interface loopback 1, what if I do the trace there? Because now it's a /24. And sure enough, we are now load balancing again. So all I would need to do on my Cisco side of the house is go into interface loopback 2 and say IP OSPF network point to point, interface loopback 3, and say IP OSPF network point to point. And now when we look at our routing table, how are those 192.168 prefixes being learned? Now they're seen as /24s. They're no longer seen as /32s. So then what we set up initially is correct. So if I were to say run trace to 192.168.10.1, you can see that we go to 10.221, and then we're going to jump over to 10.111. What if I trace out to 20 now, to 20.1? Take a look at that, right? It load balances out for us, goes to 10.221 and then 10.111, and then finally, let's take a look at 192.168.30.1 and see that the load balancing is, in fact, working. So yeah, I look back at the routing table and realize that we were not advertising those as point-to-points, even though they're /24s, they're loopback addresses, so they're not going to come out as they're not going to be learned as /24s, they're going to be learned as /32. So we had to change the network type to point-to-point, so then it matches the statement we have here. The other alternative, what we could have done was I could have rewritten the route filters to go down to an exact match with the .1 as a /32, and then we wouldn't have to make the change on the Cisco side of the house. All right, so that wraps up sort of part 2 here of the Cisco and Juniper OSPF interoperability tutorial. We took a look at IPv6, how to set IPv6 up. We saw that we can't leave it as the default /128 with our link local addresses. We went ahead and made them /64s on the Juniper side, and then our adjacencies came up perfectly. We saw multiple ways to test the load balancing, and that the load balancing on the Juniper side, equal cost multipathing, does not work by default, that you actually have to set it up in order to get it to work. All right. Well, that's all we've got, and I appreciate you watching. Hopefully this has been beneficial to you and you know a little bit more about OSPFv3 on Juniper and Cisco, as well as a lot more on the load balancing, the equal cost multipathing on the JunOS side of the house, and how to validate and confirm as to whether or not you are doing equal cost multipathing on the Juniper side of the house. All right, thanks for watching. Have a great night.